Okay. All right. Hopefully everyone got back. So let's begin for the second section. So please. Okay. All right. So let's move on. Second section. New topic. This week, I want to talk a little bit deeper part of the functions. I know. So what we learned earlier, learn function, just like what we earlier last week homework part, right? So when you say y equal ax squared plus bx plus c, and we define this part is fx, right? Same function x. So it means x changing. When x changing, y keep changing, that one as well, right? Is it correct? So you can see here. So you can see here like this kinds of question when you do whatever fx. So any degree earlier we also use a linear line part, right? We right now extend to this one, right? Quadratic equation part. All right. So what's the composition? What's composition? So it's multi. So it's just like layover. Looks like try to lay over composition of functions. All right. Question. So maybe say we can say this is another function inside. Suppose say here is already x. When you never give x, the initially has one function, and then this function inside this function. Right. So this is called composite. Right. So let's go to the actual explanation. Composite function. Now, so it's what I say. Composite function definitely have two functions, right? Functions have two functions. One of them is f, the other one is g. So denoted as just like say if this one is inside, they can describe like this. So this equal like this. So it means looks like this one is what earlier we talked about. Right now, the x inside one is actually another function. So they can describe like this one. So we have to figure out this question first, this function first, and then got the second part, right? So whenever define like this, so it means we need to figure out the second one g first before we figure out the second function, the higher level function. Okay, so that's what I say. And this FOG can describe here, this a little bit better to understanding here, right? This is the initial x inside, but right now replaced by another function called g function. So they use the different methodology to describe it. Like this one is what I talked about. This is best description, we easy to understanding because we initial function is inside. We know x replaced by another function. But when they describe this way, we better translate this way. Whenever even they are described this way, we also try to translate this way. Don't try to change the sequence f and g, because try to do the g first, right? G first, g inside first, and then go back first function. So something need to be careful here is in order for the value of x, should be just like the gx is all the final value should be the domain of the should be in the domain of the first function. So two conditions must be satisfied. That's important. First, x must be in the domain of g. So make g not just make it undefined. Cannot make it undefined, right? Should be in the G, be in define of the G function. So after the all Gx must be in the domains of F. So that's two functions. So whenever you can see here, whenever initially you have F, initially what we earlier thought is less X here. But now this X is replaced by second function, right? So second function should be the same domain, just like all the values should be in the X, this initial value cancel domain. Right. All right. So let's give some example. I know theoretical part is a little bit confusion. And up to now, you guys maybe have not met this question, but if you go to the SAT level 2, subject level 2, level of question, have a lot of questions like this. So definitely have a question in this level, right? Right. So give an example. So let me clear screen first. So first, after that, you can see first function is fx equal x squared plus 1. Okay. Second function gx equal x minus 2. So just like we say, let's see A. So f, right here, we just rewrite it into like this, okay? Make it easier understanding. So you can see here is f gx equal what? X minus 2, which is x minus 2. So you can see from these functions, when function x equal x squared plus 1, so means whenever inside was changing, whenever inside here was changing, right? We change into here. So all the x will be replaced by x minus 2, right? So it will be equals to, so x initially is x, right? Right now replaced by x minus 2. It's 1. So it became like this. So it will be like this, right? So would be equals to, so this one will be much easier. You can handle this, right? So would be equals to x squared minus 4x plus 4, right? So actually it became plus 5 when we put one additional 1 in there. So that's it. So for first one, this one would be easy because we first we transform this FOG into like this, and this part was replaced by x minus 2, and then x2 replace the initial x in the f function and do some simplify. So that would be easy. So this part actually equal here, equal here, and equal here. So last one would be this here. But the second one, we see the B. What about the change sequence? Change sequence. Change. Let's see the change this sequence. When you do the change this sequence, what we do? What will it do? All right, so first, let's see here, we see Z. So this one would be G. We change like that, right? G like fx. So what is fx? G fx equals what? X squared plus 1. So inside here was changed by x plus 1. So G equal x minus 2. All right, so all here x will be replaced by inside at least x plus 1. This x replaced by whole part of here. Right? Became x squared minus 1. So this part actually finally equal here. Okay, so this is C. Actually, C is this part earlier. We should do it together with the A. Okay, so let's see the C here. So we can change here, right? So here x replaced by 3 now, right now by 3. So we know G equal x equal 2. So will be became 1, right? It became 1. So 1, put it right here, will be 2. So this means this part equal 2. So this is a composition of function. This is the basic part we need to keep in mind, don't try to change sequence, just like say A times B equal B times A. Here, F compositions of function G doesn't equals G function F, right? So this cannot change position. That's critical part. Okay, let's see more detailed information. Detailed example you potentially can meet in near future. Okay, so let's see. If first function F, they have this kinds of relationship. So F, let's be right here. So it's not a totally linear, right? So we say here say X, here is F. So if -1, you got -3. If there are 2, you got a 5. If you here X got 4, you got 1. What about G? Let me change the color. G. So X and G. Okay. So if -2, you got 2. If 1, you got 3. If 6, you got -1. Right? That's all we provided. Find the flowing equation equals to what? So here we should find G -2. G -2 equal 2, right? So we got 2, and then put it to the function F. So this part, what we here is we need to do theory like this. We find G -2 first. So it's G -2 actually equal 2, right? So equal F2. So F2 here equal 5. So we can go. Well, let's see second. So let's describe this way. Don't confuse things to us. So it will G F4, right? So F4 equal 1. So you like G1. G1 equals 3. So it will be 3. You need to find here. So this B will become 3. Let's see C. C, so F, G, we use the 6. The G6 first we find equal -1, right? The G -1. So from here, you got -3. Way much easy, right? Way much easy. So only thing you need to understand their description and what it actually means. All right, let's see a little bit challenging. Well, so the earlier one is give the just detailed process, just like a process with explanation. So let's see a little bit challenging one, if they are actually function. All right, so this one is already described this way, make it as easier, right? So FG3 is bigger one. So we need to do this part first. This part change what? Can 2 minus x, so became 2 minus 3, right? 2 minus x. We should prove minus x to 2 minus 3. So equals f -1. F -1. So we use the equation of here. So 1 minus the x replaced by -1, right? You got here. So you got 6 over 2 equal 3. Right? So the answer will be D. So this one just try to capture what do you accept, what's the composition on functions. Right? Is it good? Anyone have questions of this part? No? Okay. So I'll move on down next. Next topic is called recursive formula. Recursive. So what recursive formula is means let's use to something happen the same pattern. So a recursive formula for a sequence describe how the nth term from the terms before it. So like if you just like, let's say a sequence term, there's a lot of terms. The first one is given, and the second one, they have definition like a formula related to the term before this one. So when this one was given, they have same pattern after proper, this one got the third one. So they continue move on. So whenever the n word would be. So when you know the n term here, there's a lot in between. So you need to the n minus 1. And n minus 1, you need the n minus 2. And you need to go back to find what's the initial. So whenever these kinds of sequence was given, first thing you need to basically give you, at least need to give you the first term, what it would be looks like. And second one, what are the pattern, right? The pattern would be called recursive formula or recursive function. So that's two of the initial made up. Firstly is the initial condition that shows where the sequence starts. That's what I say. Just like the first term, they give a multi-terms, like the function when x equals 0, when x1, x2, x3, x4, right? You get the function. Based on function, you get the answer. That one directly related to x, right? Whatever current function, what do we have? X, y kinds of function. So y equal x. So whenever x was given, you can determine y through the function. Is it correct? Anyone understand this step? But the right least kinds of pattern is not. It is, say, they determined by previous term, not by the x. So looks like have some more relationship with the n. So given n, they give you formula, give the initial one. So you need to find out how they decided. So looks like accumulated. Each one is accumulated and replicated the first pattern, right? So looks like they are continue doing this one. Just like earlier, we have replaced inside, right? Where the composition of function is replaced inside one time. But right now it's replace inside. It repeatedly. So recursive is something like give like this way. So let's say first give you $2. Well, first give you at $1, right? So let's say I always the one after you do time, I always double it, right? So I got second one got 2, and second one was a 2 times 2, and 2 times 2 times 2. This is became what? So these kinds of pattern or duplicate the first one. Always the first time double. The first turn, the turn in front of the double. So we know this one became exponential index. So we know the first one is 1 is say 1 times 2 power 0. And second one is 2 power 1. And third term will be 1 times 2 power the third one minus 1, right? So when you go to n, it became 1 times 2n minus 1. So you know the pattern. The first one would here, second one. The first one is here, second one is 2, right? The third one will be here. And the nth one will continue move on. The nth one will be like this. So this became exponent dex. So this is also duplicate kinds of pattern as well. Just like you got an interest, your money put in the bank. Every year he say give you 5% increase. So first year if you put $100, right? The second year you got initially you put $100. After 1 year they give you 5%. So you got 105. So 105 is come from initial 100, you plus 0.05%, right? So you got 105. And the second year, so it's based on 105, you times 0.5 again, right? So it's kind of repeat. So your money is keep growing. So every year keep going. If you did take money out in between, during the years, the money will keep growing like that pattern. There's a lot of formula like that, a lot of percent, just like earlier we say carbon 14, every 5,433 years, the weight decrease half. That's a lot of repeat actually related to reality kinds of question. Okay, let's see the example here. Let's see example here. I think we have additional example later. Give on. So first, a sequence. See example here. A sequence in recursive defined by a minus 1. Just like we say we have a lot of terms, right? This is n term, a minus n. So we don't know what's that. But we know the relation between this term before the one, what they are relationship they describe like this. So it means the term n is they use the like this called note, right? This is note. So this term describe this one, this term describe like this one. And this term relationship their previous one is the previous one plus 2 divide n. Well, so we can see what the beginning. What beginning? They define A0 is 3. They define A0 is 3. So we can got A1. A1 equal what? A1 equal A0 plus 2 minus 2 divided 1. Right? So we replace 3, A0 3 plus 2, you got a 5. So A1 is 5. So A0 is 3. A1 is 5. So what about A2? A2 equal A1 plus 2 divide 2. All right, so A1 is 5 plus 1. So you got 6. So you can say A0 here, we can write here 3, 5, 6. We didn't find the pattern, but they have the formula there, right? So what about A3? A3 equals A2 plus 2 over 3. So it equals 6 plus 2 over 3. So equals 20 over 3. Right. So what about A3? So we can got 20 over 3. So more complicated, right? So when you go further, more complicated. The same, just like the pattern is the same. It's the one previous per one plus additional one. Let's make it complete. It's not like the one what we are talking about, right? Earlier about the money interest, about the material decay. A little bit different here. But the third one, like this, they increase in different pattern. Let's see more example, at least for these kinds of recursive function. Sorry. Get rid of this. Okay. All right. So see this one. Okay. So this is composition. Do you see like that? So, all right. So like these kinds of description, we first need to find figure one, function one first, right? Let's see function one. So it'll be 1 squared plus 5 square root. So square root 6. All right. So we do this part. Second part. So we can rewrite it here. We write like this. So we know this part is equals 6 square root 6, right? We replace here. So square root 6 x squared equals 6 plus 5. So square root 11. All right. Let's see the third one. So we know this part is equal square root 11. So here is 11, right? So we replace x with the square root 11 square will be 11, right? Square root 11 is 5. So then 4, 16, right? Putting 4. So the answer will be 4. So you can see the first pattern is 6 square root square 11 square root 4. Just duplicate. We call recursive function. All right, let's see some a little bit more challenging part. All right, I need someone to help me read it. Jonathan, are you there? Can you help me read this question? Make it you a little bit louder, okay?
For next year's vacation,
okay. I'm sorry.
Cabrera deposited $2,000 into a savings account that pays 0.5% compounded monthly. In addition to this initial deposit on the first day of each month, he deposits $200 into the account. The amount of money N months after he opened the account can be calculated by the equation.
Okay, you don't need this right equation. Yeah, next sentence.
According to the formula, what will be the amount in Cabrera's savings account 3 months after he started it?
Thank you. Thank you. All right, so you can see this part here. Yeah, a little bit different, right? Just like earlier we say saved $100 at 5%, so it's not changing the base. So right now it's a little bit different. Every month, the person called C or the C, he add additional 200 into there. So it will be changed a little bit. So formulation will be changed. The formula changes. These kinds of conditions. So let's see. So first month already given. So we say initial, okay? So you already is $2,000. So what's the first month? First month, so would it be initial? So would it be, so this one would be 1.005, right? Time 80 plus 200. So initially he earned what? He can $10 more, right? So it means $2,010. A replaced by 2,000, right? Plus 200. So you can get $2,210. So initial the interest $10, right? And he put an additional 200. So he after 1 month, he already have so much amount in the deposit in his bank account. Second, and right now in 0.05 time. So right now the base change to this one, right? So A1 will be replaced by here, and also he deposit another $200. So it's good. He every month put additional money there. He keep growing there, right? So you need some calculator to get here, and then A3 after 3 months. So this is after first month, after second month, after third month, right? 3 months. So you need to put this number. You get this number time 0.5. This number come down. I didn't calculate it here first, and then put an additional 200. And that's the final answers, right? So you go find a little bit complicated kinds of. This is not so complicated as we thought, but it would be easy to understand. A good example to explain recursive formula. Okay. Right. So let's move on. Third, another question, a similar one. A sequence of recursive defined by, oh, there's more here. More complicated, huh? So actually, you can see the first one. I mean, the before term and after term have somewhat so complicated relationship. Very complicated here. I don't know how to explain, to be honest. But let's describe such a way. All right. So let's see. If A0 equal 1, A0 already equal 1, we give you the initial one. So if they give the initial one, we better we can do what based on what they describe, right? So we just try to say a n plus 1 equal a n. So this is the previous term. This is the next term, no, next state. Minus so fx. So we just replace so an, right? So actually here is we actually replaced by an. So it became an squared minus 3an. Down, the bottom one is gan. So 2an minus 3. The very complicated kinds of situation. All right, so let's see. So it is A0, right? So that's A1. A1 we say A0, we replace A0. Right. So A0 already told us is 1. Okay, so it'll be easy. Right? So here became positive 2 divide negative 1. So 1 minus negative 2, negative 1. So you can got negative 1. So A1 got negative 1. What about A2? All right, A2. So all the here, this question 1 became A1, right? So A1 was just negative 1, was just replaced by negative 1. So everyone notice do this process, right? Okay. All right. So you here would be easy, right? So negative 1 minus 1, and no space here, plus 3, and negative 2 minus 3. All right. So can you guys take your notebook? What answer would it be? What do you guys got? Our 5, right? I hope you guys got same as mine. I know. So negative 1 minus plus 4 over 5. I got a negative 1 over 5. I'm maybe wrong. Negative 1 over 5. Do your calculations here. Can you guys do this? Let me use top here. Minus 1 minus 1 plus 3. The bottom here is negative 5. So here became positive. So here is negative 1 over 5. Yes, that's 5. So answer would be B. Is it right? Is it correct? Okay. All right. Everyone got same answer as mine? No. Okay, let's move down a little bit. So exposure, let's go a little bit more here. I think that's more critical for us because we made many kinds of questions like this called exponent function. Exponent function, just like we say here, is actually you guys maybe know this one already. Just like as right now we talked about double fractions 1, and then every time it's double the front. So here can 1, actually here 1 can be changed to a, all right? So the nth will be here, and the n plus 1 will be 2 power n, right? So you can describe this one is 2 n minus 1. So if you is n, you know the function at least. Right. So this is the earlier what we talked about. Every time if you double previous one, you can get this kind of exponent function. So let's describe it more generously. An exponent function is in the form actually in this format. A times b over x, right? So b So when you can imagine here, when the B, so suppose A is not equal 0. If A equal 0, everything is equal 0, right? So A definitely cannot be equal 0. Should be some decent number. And B is positive number, but B equals 1. If let B equals 1, here always equal 1, right? Whatever time power will be equal 1. So it will be split a little bit different. So when the B greater than 1, so would it be, you can see this number here earlier, say for 2, every time it's been became bigger, right? So you can graph in here like this. Initially it's 1. When the power is 1, it's got 2 and 4. So it looks like they pass like this way, growing. You can see this is 2 power x, right? That's the 2 power x. So when they got 0, always got 1. They always pass 0, 1, right? Always pass. But if you replace by here, x equals 0, y always equals a. So increasing like this way. So dramatic increasing. So, so the function will be not linear anymore. Earlier we talked about linear question. Here, parabolas, yes, they also grow like similarly like this, but this one is go even quicker. It's grow very quicker. Go this way. So y equal 2 power x. Go left. Okay, what about b equal 1? Just like say, if they equal 1, b power x. So always equal 1. So it's constant, right? It's always like constant. Like this. Whatever number will be, they always flat, become horizontal. But what about b is in less than 1, greater than 0? Suppose it's half. So each time is grow, just like the decay, right? Decay. Oh no, cannot go down, but they're always above this line. In between 1 and 0, they always go here. Let me use different colors. So should we go? They also cross this 0, 1. So, but it also goes down, never cross to the x exile. So it's decaying, just like initial very big and grows down, go slowly, but very close to the 0 when it goes super bigger. So one of the example, I think this is well described, the one what I talked about. So half of that one. They cross 0.1 here, right? They cross power here. But when they keep going, they will be very close to x, but never cross to x. It's very close. So if someone can maybe learn limitations. Anyone of you learn limitations? So when x goes to positive infinity, y will be 0. Very close 0, but not equal 0. The limitation will be 0. So you guys, if you go this one, the limitation of 2 power x, that's no exist. It's limit we'll call maximum. Right? It can go to the infinity. So have 2 different kinds of direction. This one called keep growing quickly, and this one is called decaying. This one called growing. Like the money one, right? Money always keep growing. If you give additional interest, it keep growing. If like the element decaying, so 2 different ways. So 2 different kinds of methods. That's why exponential function that always become one of the questions in the SAT because of a lot of reality will happening here. Let's give one example. Let me give one example. Okay, so you can see here. All right, so let's do a little bigger. In the diagram below, each exponent curve represents the population of bacteria in a Petri dish as function of time. Oh no, bacteria growing in hours. At the time of T0, the population of the dishes, 1 is 2,000 and population 2 is 3,000. Well, they're both growing, they have different base, right? Different initially. So we can describe to see how it's happening here. So when one plane is 2,000, it grows much bigger, right? Much quicker. And when they grows to 4, they grows to 10,120. And the second dish is actually initially 3,000, but a little bit slower. When 4 hours, they grows to 6,220. So at the time 20, the numbers of bacteria in dish 2 is what percent more than dish 1? Also easy. So 50% more, right? 300 over 2, 3,000 over 2,000 minus 1. So equal half. So it's 50%. Sorry, here writing is so bad. Find the average growth rate of bacteria in dish 1 and dish 2 from time t0 to t4. Average growth rate. If they average, it means try to make every step is the same. So average in t time 20 to t4, the growth would be what? So would be 10,120 minus 2,000 and over 4, right? This is dish 1. What about dish 2? Dish 2 would be 6,220 minus 3,000 over 4. Over 4. Right? So dish 1, dish 2, their average growth was totally different. So this is just chart. They didn't relate it too much exponent. They give you too much of this part. Okay. So I will put additional question in the homework. I have 2 more questions actually. I prepare maybe too much of them, but I put this one in the homework part. You guys can use it as homework, finish them. And I will send additional, a little bit challenging part as AD text. Actually, I already list here as the homework. This is a little bit challenging, not like last time, like the earlier work. Here, maybe a little bit more change. Please do this part right. I will send it as a homework. This is called XAT practice text 5. That's a little bit challenging. Okay, so I will be send these 2 out after classes. We are a little bit delayed, but it's fine. All right, sounds good. And I think that's all for today. Do you guys have any questions? No. If not, I will stop recording and see you next week.